People, okay.
Hi, everyone. This is Caroline Griffin. I am Riot's Director of Operations. You have found the Riot Lunch and Learn series, the place where we feature all of Riot's sponsors. I'm super excited to have Jon Buchwald with XGR Technologies here to talk about how a simple solder sphere solves today's EMI shielding challenges. Just a couple of reminders before we get started. Please do keep yourself muted throughout the presentation. And if you have any questions, please do place those in the chat box and we'll make sure they are answered. But without further ado, I will hand it over to Jon. Jon, thanks for being with us today.
Okay, thank you, Caroline. And thanks everyone that was able to join. I appreciate you taking the time out of your day to learn a little bit about our unique board level shielding technology. I'll get into a little bit of background. I assume most people are aware of this, but I hate to make those assumptions. The electronic devices, as we all know today, are getting smaller and smaller, and the demands and expectations around performance are just getting bigger and bigger. So this is especially true with a lot of today's wireless devices that include the technologies that we're familiar with: Bluetooth, Wi-Fi, GPS, and 5G is especially driving the need for greater EMI shielding in our devices. So the device, has to be electromagnetically compatible with itself and also with the external environment and complying with government regulations. And as these devices proliferate, that compatibility and coexistence becomes increasingly challenging. The traditional board level EMI shields are typically there's the one piece can that goes over top of the circuit. There's also very common and probably more common is the two-piece frame and lid styles, or a two-piece that has a clip and then the shield that clips into it. These shields are attached with various different methods. For example, at the top here, you see where it has pins that go through the solder board and then are soldered onto the board. And they can also be directly surface mounted and soldered directly to the surface of the printed circuit board around the perimeter of the shield. And then all the way to the right, you see there is a clip that's initially soldered to the board, and then the shield is clipped in place afterwards. And the reason I bring these up is because one of the technologies that's very unique and valuable with SnapShot is the attachment mechanism, which I'll go into greater detail in a minute. These board level EMI shields can have typical shortcomings, which would be they consume excess board real estate. And as I mentioned, devices getting smaller and smaller, that board real estate is really at a premium and really valuable to the design engineers. They also can make it challenging to inspect and rework if necessary after the reflow process. Shields also can be challenging to remove once they're soldered in place. The two-piece shields, where it's the frame and lid style I mentioned, those are typically less rugged than a SnapShot shield, and that's because of the movement that can occur between the frame and the lid, providing the shielding. In general, and we'll show some data here to support this, but the two-piece shields provide lower shielding effectiveness. And they also are constrained in terms of the design and shape. Typically, they are squares and rectangles or shapes with a lot of straight lines. The SnapShot totally removes those constraints. And in some applications, such as wearables, handhelds, anything in flight, drones, these shields can create excess weight, which is not desirable in those applications. The basis for the SnapShot shield is the unique material. It is a polyether imide base. Most people know that as the trade name Ultem. And that is plated on a single surface with tin, which provides the shielding. This engineered polymer has a high operating temperature, so it's workable in just about every application. It goes up to 170 degrees C continuous. And you can see it's a very thin shield, taking up, again, less space and less weight at 0.125 millimeters thickness. The process for creating a shield is we start with a design, and you can see here, this is actually goes into a consumer GPS watch, and the watch is a round shape. So we've got some radius edges there, corners, and it's a multi-cavity irregular shaped shield. You could never do a shield of this design with a frame and lid style, for example. A mold is created, and the part is thermoformed, where it's heated to soften that polyether image, and then thermoformed into the desired shape, and laser cut to create that finished part at the end. Again, each application, it's totally custom designed, and lots of freedom of design in terms of the shape and size. The attachment mechanism, that's where the title of this webinar comes from, about the solder sphere solving many challenges. These shields utilize a small solder sphere that's soldered to the board just as if it's any other component. And then the shield itself has small oval holes around the perimeter, which actually snap over top of these solder spheres to create a very robust electrical and mechanical joint. And I'll show some details about that. It's very unique, very different, so it's not necessarily intuitive to everyone. And you can see this is an illustration showing there's 2 points of contact at every sphere. And again, that ensures both mechanical and electrical contact to the conductive surface and also the ground plane, which completes the Faraday cage of the shield. Now this represents, you see the oval hole around the perimeter of the shield is smaller than the diameter of the sphere. So it is aligned over top of the sphere, a force is applied downward. The material is somewhat flexible, so it can flex around the solder sphere, and then it snaps into place, hence the name SnapShot. And it's an audible snap that, again, it creates a continuous force exerting the shield to the board. Now, to apply that force, there is an installation tool that's also provided by XGR during the final design process of the shield. And that simply provides teeth that go around the solder spheres and press the shield into place. And you can see here in this example, the installation tool has alignment pins, and this ensures that the shield goes in the exact right place each and every time. So as this shield is installed into the installation tool, it's aligned over top and then pressed into place. And typically this is done with a pneumatic press. It can be in low volumes or prototype volumes. It can be a hand press, and in high volumes, it can be fully automated. And here's the diagram of a typical process flow, and most people will ask, how are these solder spheres attached and what special equipment is needed? And the answer is actually, the easiest thing to do is think of them simply as another component. For example, an 0201 resistor. They are sold in tape and reel format. That's a standard. It goes into the chip shooter machine. Again, could be right next to a tape and reel of resistors. The solder paste is applied to the board for the spheres and all the other components in one step. The spheres are placed onto the solder paste, and the board goes through the reflow oven. Now, once it comes out of the reflow oven, all you have there is the solder sphere. So you have the ability to do the inspection and rework if necessary, and then the SnapShot shield is installed. And this, again, it enables, complete inspection, whether that's automated optical inspection or visual inspection, and then very unobstructed rework for any of the components. And one other unique feature here is it is completely removable and replaceable without any additional heat steps. So if there is a situation where the shield is installed, testing is done, and some tuning needs to be complete, then the shield can be removed and reinstalled, again, without any more heat and no damage to any other components. Here's a real world example of the increased ability for inspection or rework. Is 2 high-end GPS watches. The one on the left is using frame and lid technology, and the one on the right uses SnapShot. You can see, if you compare the obstruction created by that frame and lid, especially to those components that are immediately adjacent to the frame, it's really going to be difficult, if not impossible, to inspect those solder joints and also to do any rework. Whereas on the right-hand side, the solder spheres enable a very wide open view and wide open access. I would say this is probably the most valuable to customers that we encounter. And I mentioned space savings, and to do that, I'm going to take an actual solder stencil that was provided by a customer that shows here 4 distinct frame and lid cans that are situated adjacent to each other. And if we take a look in more detail at this area where 2 shields are adjacent and understand the width that is required for the 2 rows of solder pads, it turns out to be about 3.8 millimeters in this case for this customer. The SnapShot shield between cavities only requires a single row of solder spheres, which completely isolates the 2 cavities, and those spheres are 0.9 millimeter diameter. Now, the shield does have a draft angle and some thickness, so it's not really fair to compare the 0.9 millimeter to the solder pad, but still, in this case, we have 1.7 millimeter width required for the sphere and shield on 2 cavities. And that's greater than a 50% reduction in width across that area. Now, saving space in the Z direction, or the height, is also critical in a lot of handheld applications. And again, that GPS watch, they really valued the ability to have a low profile. And if you remember, the underside of the shield is polyether imide, which is non-conductive. So there is literally 0 clearance required between the top of the component and the bottom of the shield. So that, and in many cases, it's intentionally designed so that the shield has contact with the components. So there's literally, it enables the lowest profile shield available. A common question, given the unique nature of the attachment mechanism, is, hey, is this reliable and rugged in extreme or harsh conditions? And the truth is, it is yes, and it's actually more reliable and rugged. And SnapShot has won several applications just based on this fact alone, where it was the only shield that was able to pass rigorous shock and vibration and tumble testing. So these solder spheres, again, it's 2 redundant points of contact with exerting constant force, downward force on the shield. And given the lightweight nature of the shield, it results in very low forces being imparted on that shield. And the shield is, as I mentioned, somewhat flexible. So there is no co-planarity issues. And during any kind of shock or vibration, it can move and avoid any type of solder cracking or shifting in performance. The technology has been out in the market for over 18 years and has won many applications in these demanding applications. And the ones that come to mind, military handheld radios, you can imagine those have a very strict and harsh demanding requirements. Military and industrial drones, the industrial handheld scanners. This is the application that I mentioned that has really crazy drop testing requirements. And it's even been placed in the nose cone of a missile where it's experiencing 17,000 Gs as the missile is launched. So yes, durability, ruggedness is not a concern. It's actually a very strong point for this technology. I talked about the space savings with the adjacent cavities, and that's enabled because this is true multi-cavity performance. There are a lot of technologies that claim multi-cavity, but in this case, the shielding effectiveness from cavity to cavity is really, it's equal to the shielding effectiveness from the cavity to the external world. That row of solder spheres completely isolates the two adjacent cavities. So what that means is you can take one shield and have 9, here this is 9 independent circuits that are isolated and comes into one shield. So this could and does represent a space savings, a large space savings, and a cost savings. When we're replacing 9 discrete shields with one snapshot shield, customer is seeing not only just the component price savings, but also savings in logistics and installation and yield improvements. It's probably obvious by now, but the shield can be formed into virtually any shape. So it's really up to the imagination and the design requirements of the board. And an example again is that round shield and either the nose cone of a missile or a watch, but radiuses, angles, irregular lines, the multi-cavity, and perforations for heat dissipation. All of this is accomplished very effectively with the thermoforming molding process. And I mentioned the lightweight, and this is a comparison of a typical frame and lid that's even actually on the thinner side, so lighter, but versus snapshot. And it represents it's a 80 to 90% weight savings. In a recent drone example, we were about 12 times lighter than the technology, the alternative technology they were looking. And this is a handheld drone for military applications, and they require actually 6 shields within that single drone. So, you know, in applications where those grams matter, this can deliver a big benefit. And finally, it is an EMI shield, so all these things can sound great, but if it doesn't perform as a shield, then it's not going to be that useful. But because it is installed after reflow, it's typically compared with or replaces the 2-piece frame and lid style shields. And here's a head-to-head comparison where across the spectrum from this testing, it really went from 250 megahertz up to 8 gigahertz. And the shielding effectiveness is 20 to 25 dBs greater across that entire band. And in reality, the performance continues to be that way up even through, say, 18 gigahertz. So yes, it is a shield, very effective EMI shield with lots of other benefits that can be valuable. You can see it's used currently in virtually, I mean, every industry you could imagine, you know, medical electronics, wireless handhelds, drones, GPS, and network computing. So with that, we are ISO certified, ITAR registered, REACH and RoHS compliant. And I invite you to contact me directly if you have interest in receiving more information or a sample. I'm happy to send out samples to get a touchy-feely impression of the technology, or you can visit us at our website and submit a form for more information or a sample that way. Again, thank you for your time, and look forward to hearing from you.
Thanks so much, Jon. We will now open the floor for questions. So please, if you have any questions for Jon, feel free to unmute yourself, or you can use the chat box. Don't be shy, everybody. It must have been very thorough, Jon. Well, I appreciate everyone joining us. Again, this presentation, I know a lot of people jumped on kind of a little bit in, so it'll be posted to Riot's YouTube channel and then shared for the meetup group where you registered. And I encourage you to reach out directly to Jon if you think of any questions. Thanks for being with us, Jon. We appreciate
Thank you. And again, it really is something to see it on slides, but it's a whole nother thing to see it have a sample in hand. So don't hesitate to go to the website and submit a request, and we'll get some samples out.
Amazing. Thanks so much, Jon.
Thanks, Caroline.
Take care, everyone. Bye.